let's explain the difference between circulatory lift force and non-circulatory lift force in an intuitive way. First, we will explain the circulatory lift. So, assume there is a flow coming from the left of the airfoil, having the properties of V naught and P naught. V naught represents the velocity, and P naught represents the flow pressure. So after hitting the airfoil, that flow would get split into two sides or two portions, upside flow and the downside flow. So if you take 2 points, one point on upside flow and the point two on downside flow, these 2 points would have different velocities, and ultimately they would have different pressures. So that pressure difference is going to create a lift force in the y direction on the airfoil. So a lift force that is produced due to the shape of the airfoil, because it's going to split the flow into two portions or sections, and it would create a pressure difference between the flows, upside flow and downside flow, and as a result we would experience a lift force on the airfoil. So it's a shape dependent property. So the next is, what is non-circulatory lift? So assume there is a fluid particles, black dot represent the fluid particles, and let's say your airfoil starts moving up and apply the force on the fluid particles. And then if you see the free body diagram from the perspective of flow, there is a airfoil force that is getting applied on the fluid particles, and with a value m into acceleration into y direction. So using the Newton's third law of motion that states that the action and reaction are equal but opposite in direction. So as a result, the lift force or the fluid force experienced by the airfoil, that is the reaction, is equal to the negative of the fluid or the force of the airfoil. So it's a reactionary force. So when airfoil starts applying force on the fluid by going up and down, left and right, or even rotating, there would be a reaction to the airfoil motion from the fluid, governed from the Newton's third law of motion, and it's not dependent on shape of the airfoil, rather it's a motion dependent property. So the airfoil would experience a non-circulatory lift. So in order to sum up this whole thing, when your airfoil is static, that's a steady case, your total lift is basically equal to the lift, non-circulatory lift part and the circulatory lift portion. So in the steady case, because the airfoil is not moving, so the non-circulatory lift is zero. So the total force comes from the shape of the foil, that is circulatory lift. So when your airfoil is dynamic or moving, that is the unsteady case, your total lift is coming from two portions: the non-circulatory lift portion and the circulatory lift portion. And in this unsteady case, the lift because of the non-circulatory part is not zero, because airfoil is moving up and down. So that's the intuition behind circulatory lift and the non-circulatory lift.